questions for the panel on tipping points, thresholds, regime shifts?
Hi, I have a question for Jackie. So with the current idea is that these, at least on the Bering Sea shelf, the spring, summer blooms, export to the benthos and fuel all the benthic life. Now, how do these organisms survive thereafter? Like presumably that phytoplankton material has a short lifetime.
Actually, no, I didn't. Hello? Yeah, they actually, we can actually see viable carbon over the winter. So it's like the parts of the Antarctic where a lot of the cells are actually kind of saved in the surface because there's a lot of bioturbation that goes on. And so a lot of the carbon actually that's vectored northward gets saved in the sediments, the phytoplankton part of it. But also, these animals, they're boom and bust creatures. They're adapted to that. I mean, we have about 500 clams right now that are we've been running acidification projects. And they will, if you feed them, they'll eat them. But if you don't feed them, they're fine. So I think that these animals are used to kind of going into a slower, they're breathing, obviously, and recycling over the wintertime, but they don't need to have it all year long. And like I said, I think there is this savings account that goes on with the sediments. And since that water is always going northward, there's always some advection of carbon from the south going north. And that's the first production that happens in the south, in the southern Bering Sea. But they can tolerate a lot.
So I have actually another question for Jackie. This thing about the fining of the sediments, I don't know if I missed it, but what is the mechanism for that actually happening?
Well, it's an interesting thing because we have the deposition that's going on south. It's one of these conveyor belt too, south of the system, because I talked to Tom Weingartner about this, about the physics. And so that water is kind of corrosive as it speeds up to go through Anadyr, which is the western side of St. Lawrence Island. Once it gets north of the island, and it has the ability to take up finer particles. And so what we're seeing is that a lot of that finer particles that used to be in certain regions is actually being carried northward and then deposited down in parts. So it's an interesting thing with this changing between the dynamics, the variability of the different coastal and the Anadyr water. So an area that used to have faster currents is slower, and that's what we're seeing more north, and that's where appears to be the fining that's going out. And I think that's why it's a current-directed. Not everything is beautiful like our conceptual models, And so what it's telling you. So we use this. We just published this paper with Bob Picard's student and from Russia, and so we're using all historical data and related the current speed with the grain size and looking at that type of dynamics. And I think that's what we're picking up on indirectly. Besides those 5 current meters we have in that system.
Anything else?
I have a question for Mary. I wonder if you can comment how informative would be for something like what you're doing, the studies of recent changes in, for instance, Holocene communities of deep sea corals, like within the last, say, 5,000 years. Would it be of any use for you to look at changes in distribution of those?
Yes, that would be great to look at something like that because, like I said, I don't have access to time series that usually go more than 30 years or 35 years. So having those really long time series from real systems would be a great way to test the method.
Yeah, there are some collections available which have dated corals, and yeah, maybe we can talk.
Okay, thanks.
Hi, it's another question for Mary. I'm just wondering, because we're talking about regime shifts and possibly going into like a no analog situation, aren't some of these tipping points just naturally unpredictable? Like, what do you think about that?
Yeah, I get that question all the time. Is it actually realistic for us to be able to identify when these tipping points exist? And I don't think the methods, at least the ones that I'm talking about, are going to tell us when they're going to happen. But I think going back to sort of monitoring and having a baseline of the variability in the system. If we can, it's sort of in my opinion, that if we can sort of monitor the change, monitor this variability, we can then at least try to be a little bit more cautious in some of the way that we manage the system. So if we see this increasing variability and some of the other indicators indicate that, the system seems to be becoming a little more unstable, maybe we want to sort of change our management plans so that we're a little bit more cautious in terms of, for example, how many fish we're taking out of the ocean that year or a few years ahead.
All right. If there's nothing else, let's give a big round of applause to our speakers.